In the opening credits, you saw a couple interesting shots. You saw Herb Sanborn. He works with Wes Ingram over at Ingram Enterprises, going through a speaker pump, setting it up on their essentially their dyno machine, and exploring the problems with that particular unit before they start the rebuild system. And in the second shot, you saw a set of very custom pistons. And if you look carefully, you also saw a speaker pump that was black, along with some very interesting, rather sexy throttle bodies. Those are TWM fuel injection throttle bodies that are adapted to accept the Spica fuel injection system. These are alternatives to the norm, if you will, when it comes to fuel delivery on your Alfa. We are going to show you in very near future video what that particular system can do for you. It's the best of both worlds. It has the sexy exotic look that carburetors can have, and it has the incredibly powerful delivery that fuel injection can provide that carburetors just simply cannot make up the difference for. Okay, so we finally get into the video that an awful lot of people have been requesting, and the video has been on tuning your carburetors. The reason we've been somewhat hesitant on answering this question is because there's so many things that affect the actual answer. So we decided what we're going to do is somewhat bypass the question and probably just focus on educating carburation and fuel injection, meaning Spica fuel injection, and how to address those items. Kind of bring you up to speed on the inner workings of carburation, and we'll do that as well with the Spica as well, and help you kind of dial in what you have. Because the reality of it is if your car was Spica fuel injected, you may or may not have done yourself any favors if you swapped it out for carburation. Carburation isn't necessarily an ideal scenario. Spica is actually a phenomenal fuel delivery system in many cases. Now obviously there's a range in which Spica cannot go that carburation still can. And there's also things that carburation can't do that Spica easily takes care of in its own right. So we're going to cover all those things. We're going to bring you up to speed on what it is that you should be doing with your car and its carburation, or in this case we're going to start calling it fuel delivery system, because I don't want to associate any specific fuel delivery over another. Okay, but what we are going to discuss, Weber carburetors, we've all known, are a very good source of fuel delivery. Spica fuel injection is also a very good source of fuel delivery. Those who are comfortable with leaving their cars alone, if it was a Spica car, in the States here being a 69 or newer car, it actually is probably a better performing car than a guy who put carburation on that car. And we will talk about all those things. None of this is going to be handled in one video or two or three videos. I can see this probably spanning out to several different videos, because we have to establish a baseline for everything associated with fuel delivery to your car. Now we typically know in the carburation, that's where we're going to start. We typically know in the carburation side of this that we always see DCOE 40s on most cars, meaning most Alphas I should say. And then every now and again you'll see DCOE 45s. DCOE 45 is a great carburetor. It's a very big carburetor, and it should only be on a motor that really has the absolute need for it. The one thing about the Webers and or the Dellortos is their versatility. They could be set up to almost meet any application. Okay, so whether you really ever needed DCOE 45s, or you're somebody who's just on this big testosterone kick and you think 45s is what you have to get the most out of the car, we're going to talk about that, because what we do see is an awful lot of people running 45s and they're choked down to something inside of a 40. So did you do yourself any favors, or did you just write a check for a carburetor you didn't need? So we're going to cover that. We're also going to back up and talk about the Dellorto version of DCOE, which is a Dellorto DHLA. Okay, the DHLA is actually a great carburetor if you get one that's a non-emissions carburetor. The nice thing about the DHLA is that if you look at the nomenclature on there, it'll say DHLA, then it'll have a number after it, or a letter I should say after the 40. If it's anything H or higher in the alphabet, walk away. It's not worth having. That means it's an emissions carburetor, and they actually use the alphabet just as you would think. Okay, and we'll talk about how to identify emissions carburetors over non-emission carburetors, because there's an awful lot of people out there who are chasing carburetors down off the internet via auction websites and what have you, and they're buying carburetors that are emissions carburetors, and they don't understand how come they can't get them to perform very well. Well, the thing of it is if it's an emissions carburetor, it's a carburetor that was set up very specifically for a very specific car, most likely not an Alfa, and more so, that carburetor was set up for a very non-performing cam, very non-performing valve, very non-performing piston setup. Okay, so we need to be aware of what it is we're buying when we're buying those items, and I'll help you understand how to identify a Weber emissions carburetor over a performance carburetor. Okay, because the Weber version of an emissions carburetor is actually much harder to conclude what it is over that of a Dellorto DHLA, because the DHLA, again, if it starts with H, I, J, K, and on, it's an emissions carburetor. It's something you shouldn't buy. Just simply leave it alone. Okay? So with that said, we're going to talk about Webers for now, because that's what the bulk of what most of our viewers are running. We just got rid of a car yesterday. No, excuse me, today's Sunday. So we just got rid of a car on Friday that had Dellortos on it. And somebody had put these Weber or these Dellortos on for the customer at some point in time, and it's a great performing carburetor. But what we have found over the years, for whatever reason, is that we found that the progression circuit on a Dellorto seems to be a little more effective than that of a Weber. We found that the top inside of Dellorto seems to atomize fuel and have better fuel delivery at times than a Weber. I know this is something that's going to offend people, because there's people who even have Weber tattoos, but the thing of it is it's not always the best carburetor available to you. Okay, so we're going to back up and just focus on the Webers for now, and then we'll touch a little bit on the Dellortos, and then we'll really expand quite a bit on the Spica fuel injection, because if your car came with it and somebody talked you into putting Webers on simply because they didn't understand Spica, they may have did you a disservice. You may be missing out on something that is far better than you think, and we'll explore where those limits are with Spica versus carburation. But for now, let's talk about the DCOE product, whether it's a 40 or a 45. When I'm working with a 1750 that has fairly good performance, it's good for 40s. It's not good enough for 45. They're just simply too doggone big. Okay, and if you have to choke down a 45 to meet basically what a 40 does, you didn't do yourself any favors, other than paying a lot more money for a carburetor that you didn't need. So every now and again, I'll find some DCOE 42s that come up on the internet. The nice thing about a DCOE 42 is they're in between, obviously, a 40 and a 45. And it's a performance carburetor. And though it was never really offered on an Alfa, it is a carburetor that can find a nice fit within certain performance applications in an Alfa. A DCOE 42 is really good for a mild upgraded performance 2-liter. If you have a really hot 1750, it's a great carburetor for that as well. So the reason we're talking about the DCOE 42s is because I happen to have a set here on the bench that we're going to work with to explain some of the teardown features of the Weber. Okay, and again, as we're talking about the Weber's features, we're going to talk about how to identify an emissions Weber versus a performance Weber. 42s, okay, I like the 42s on very specific builds. I like them on a mild performing, I should say a mild up performed 2-liter, and I like them on a really progressive 1750. Okay, so when I get a chance to grab these, I typically do. Okay, so in this case we're talking about a 42 DCOE 8. Okay, and in this case we're going to talk about how to identify, in fact I don't think I've ever seen an emissions version of a DCOE 42, but let's just speak in generalities again, that you're looking at a set of 40s that you're thinking about buying. A couple things to note. This is the idle mixture screw. right here. It's the closest to the exiting venturi, okay? So that is, if you can look, you can see that it's on a spring, okay, and it's way above the casting of the carburetor. That's the first indicator that tells you that this most likely is not an emissions type carburetor. Secondly, if you look right past it and it's dropped down below it, that is the progression hole inspection plate, okay? Performance carburetors will have 1 or 2, sometimes you'll see 3 progression holes. Anything more than 3 progression holes is an emission carburetor. If that inspection plate is plugged over, like a little lead slugs over it, that is an emissions carburetor. Again, emissions carburetors, walk away. They'll do you no good. The time and money and the effort you'd have to tie into those to completely configuring them to meet the expectations that you want isn't worth it. Okay, so again, emissions carburetors, leave them alone. They're not a performance carburetor. Okay, they're built specifically for a very specific motor, and most likely it's not associated with your car at all. Okay, and you'll never get the performance out of them that you simply do out of a performance carburetor. So anyway, that second hole, assuming you see one that has a slotted hole for a screw, you take that cover off and you'll see, again, ideally 1 or 2, potentially 3, and I'm going to take that off right now and see what we have in this one. Okay, this particular one has 2, I know it's very difficult to see on camera, but you can write my fingers at, there's 2 progression holes in there. And basically what the progression hole is as the butterfly inside passes over it, it draws in more fuel air mixture to help the carburation or the motor go through the progression of the acceleration. Okay, so that is that. So those are 2 huge indicators you need to be looking for. Okay, also there is, in this case because I don't have it, right next to where that plate is that we just took off, there would be a 3rd hole there on an emissions type carburetor, and it's typically an air bypass hole. Okay, that is usually a huge indicator that it is an emissions type carburetor. And again, if you're looking at Dellortos, don't form the opinion that a Dellorto is an inferior carburetor, because it's not. But it's also a much easier carburetor to conclude whether it is an emissions type carburetor. Once again, if it has a nomenclature that is, DCOE 40 H or higher is an emissions carburetor, don't use it. Anything lower typically is a performance-minded carburetor. So that's where we're at with that. Now what we're going to do next is we're going to start talking about some of the internal circuitry of the carburation to help you understand how to set up your carburetor for better performance. Okay, so what we should probably start doing is looking at each individual carburetor as actually 2 carburetors, okay? If you were to literally take a line and split it down the middle and start identifying these as 2 separate components, it's probably easier to understand how this works. Okay, so a couple key notes to point out here. One, a lot of the components on this device are of brass makeup, which means that the screwdriver selection, for example, or the wrench selection is essential. In other words, when you go to wrench off here on the filtering system, don't use a 12-point socket or a 12-point wrench. Use a 6-point because it distributes the load across this softer material over a wider span, which means that you won't have the likelihood of dents or marring off the edges. Okay, whereas on the fittings for the screws or the slotted sections, using a screwdriver that is ideally in space and ideally in width is doing yourself a great deal of service, because a lot of these, if they have not been torn out before, they're going to be somewhat resistant to you backing out the screws. So using the right screwdriver is only going to ensure that you're most likely not going to damage the surface of those. Okay, so that's just something to point out. But for now, we're going to start with the most basic breakdown on this. We're going to take our inspection cover off. That's what this manhole cover looking thing is. Underneath that manhole cover, if you will, or the inspection plate, which it really is, there is that paper filter. One, don't lose it. Two, if you don't have one, get one. Because if the float system inside here ever fails and this thing starts to get loaded with fuel, it's going to come out pouring over the top of this. When it pours over the top of this, it's going to fall directly down on the motor and potentially cause a fire. So this little paper filter is very essential to your safety. Alright, so now tilting this forward, again, we're having our imaginary line. This is technically two carburetors in one. The bottom one with no hole in the top, if you will, this is the idle circuitry, and we'll talk about that in a minute. The top one, the much longer one of the two, this is the main jet and emulsion tube. Now, these are really, really sophisticated little pieces of equipment, okay? Basically what you're looking at in this is this top piece. This is the emulsion tube holder, okay? That is the emulsion tube holder. Okay, the next piece that separates from there, this is the air corrector. Okay, and the air correctors have a little stamping on them. This is a 120 air corrector. Okay, and then we come to the actual emulsion tube, which is a fairly impressive piece of equipment when you look at the very trick drilling that has been done to this to ensure that the fuel and the air are atomizing and mixing in a correct ratio. Okay, these are also numbered. This happens to be an F16, which is stamped right there. And these can be changed based off of the application. Everything about this can be changed for numerous reasons. Improved performance, ideally matching your particular engine's build. They're also can be changed for high altitude or low altitude. That is something that Spica has an up on over carburation. If your car is a Spica system and you live in a diverse portion of the world where you have high altitudes and low altitudes, you might want to stay with Spica fuel injection because you never have to worry about these things. Whereas if you have to change out this setup when you're going from one elevation to another, that can be a bit of a hassle. Because one thing's for certain, a motor that runs rich is far less dangerous than a motor that runs lean. A motor that runs lean is going to overheat, potentially damage the motor, or even worse, blow the motor up to where the excessively rich motor, okay, foul carburetors, won't run right, struggles with power, those kind of things. Anyway, so this piece is the emulsion tube, but the very bottom piece that we're taking out of there, this is the actual main jet. Okay, so basically the way this relationship works, fuel comes in, mixes with the appropriate amount of air. This is where the air comes from. Okay, so air comes in, mixes with the amount of fuel that's being delivered, basically emulsifying, hence the emulsion tube, emulsifying that fuel-air mixture, making it a much more explosive form of fuel when the spark plug ignites it. Okay, so the relationship of all these components, no one item is more important than the other, but all the items need to work ideally together to deliver the fuel needed for your particular motor. Okay, so if you're going to run carburation, you really should have a little, what we call a little job box of various jets and whatnot. This isn't nearly the science you think it is, because ideally you're going to find that one setup that works best for where you live and where you drive. And you might have a backup set for a different elevation, but effectively that would be probably all you really need for your car. Now, obviously, if you take your car to track day events, you're most likely going to change to a different, more aggressive setup for the track. In other words, that typically is a setup that doesn't work so hot in the low end, but becomes a real beast on the upper RPM range, okay? So anyhow, when taking these apart, be very kind to them because they tend to bond to one another fairly tight, and if you use too much aggressive energy to separate them, you're going to damage them. And these little guys aren't getting cheap. They're actually getting more expensive as the need for carburation becomes less and less in our world. Okay, so now moving on to the idle circuit. What you have here are just simply two different components. You have the idle jet holder, which is this piece, okay? And you can see it also has its fancy metering holes. And then you have the actual idle jet itself. Now the idle jet is stamped. This particular one is, well, I can't really read it. But anyway, so you have two components that also have a very important relationship with one another for the idle jet circuitry, okay? So again, that's those two components, and that's what you need to know about those. Now we're going to move on to some of the other internal mechanisms about these. Okay, so continuing with the teardown of our carburetor, the top nut right here, which is a brass 19 millimeter, and again, try to use a 6-point socket or a 6-point wrench on this, not a 12-point if you can. When we take this particular piece off, this is really the carburetor's last opportunity to have clean fuel delivered to it. Okay, and again, this is one of those items that has a crush washer. That's an imperative that that crush washer is there, because this thing will leak like a champ at that point. Alright, and inside there is the filter. Do not run your carburetors without the filter assembly. Now there's a couple of variations of this type of filtering system, okay, but effectively it's just a super fine mesh that strains the fuel, and lo and behold, looking at this, we actually do see debris trapped in there. Okay, so it was doing its job. This is essential because the jetting, as you saw earlier, the jetting is so small on these that if any debris gets into the jetting or the emulsion tube circuitry and gets lodged or trapped in there, it's going to affect the overall performance of the carburetor. More importantly, the carburetor's ability to emulsify that fuel and have a nice clean burning fuel. So taking off our inspection plate, there's a couple things to note here. All right, I'm going to take the screws out of the way first. Alright, and all the screws should have, and again, you're going to buy yourself a rebuild kit. I know you're not going to try to reuse your old stuff, but these have doubled up washers. Okay, you have a locking washer and a flat or crush washer directly under it. Okay, so make sure all those go back on there, because it's really essential that these things stay somewhat airtight when they're put back together. Big thing to make though, carburetors don't need a ton of pressure. Okay, so when you're looking for a fuel pump, your fuel pumps typically for carbureted cars run somewhere in the area of 3 to 9 psi. So we have to put a regulator on them. Dellortos and Webers ideally like somewhere in the area of 1 to 1.5 psi of fuel delivery, but what they really want more than anything is not pressure, they want volume of fuel. Okay, so make sure that you're not running, an absurd small diameter fuel line to these, because it really does need a good quality volume to it. Now, if you're tearing down your Weber carburetors and you see this type of float system, that means that the last time your carburetors would have theoretically really been rebuilt, where this float was still in there, would have been somewhere in the 1980s or earlier. Okay, after that they switched over to a rectangular black plastic urethane, if you will, float system by a company called Spancel. So if you see a Spancel style black plastic float in there, that means the carburetors were rebuilt at some point in time, but more importantly, they were built somewhere after the 1990s, okay? Because, these became unavailable in the late 80s, all right? Now, we'll get to it in a minute, but the big thing to really look at here is there's where the needle and seat, I should say, are right here. When you rebuild carburetors, this is a must. That really needs to be changed out, because that wears out. That is all the carburetor has as far as safeties go, to hold back fuel from overloading the actual tank for the fuel. Okay, the fuel actually sits inside this reservoir. Okay, and it needs to be at a very specific height, and we'll get to that later. Anything above that height and the fuel starts to fall inside the delivery systems, and it starts to load fuel within the emulsion system that you can't process. Okay, so probably the most important part on the entire carburetor setup is that needle and seat. So when you buy a rebuild kit, you better have that in there. All right, and those are numbered, and I'll show you that later what they look like. But setting that aside for now, okay, we're going to start at the bottom of this carburetor system, and we're going to work our way up. The only thing that's at the bottom of this carburetor that you need to be aware of is down here at the very, very bottom. Okay, you need a good screwdriver, because these tend to really seize up. Most of the components we're looking at this point are items that they don't need a replacement, but they typically do need to be cleaned up pretty well, okay? And this very piece right here, still down there, this very piece down here that I'm digging out is your accelerator pump valve, okay? This little piece has a little distorted product inside of it, okay? And this thing needs to be clean, okay? Because this needs to function. This is the accelerator pump's ability to valve in and discharge fuel into the system, okay? So you typically don't have to replace this, but you should make sure that they're clean. And that's about the only thing you want to do with that. All right, now we're going to move into the logic section. You don't typically see on these all that often. Now I've already taken one of the segments out as to show you. But this particular piece right here, you move, this is the choke, or excuse me, this is the choke assembly body, okay? I'm just getting that out of the way for now. But what we're looking at this very point is right here, okay? That is actually the accelerator pump. This is spring loaded, so it should move up and down very fluidly, okay? If it starts to drag or has hesitations, you need to make sure that everything's very clean. Right now this one's lodged, okay? So I can't even get it to go down. There, now it's up. Okay, that should not be like that. So when that is actually functional, what you should see, the butterflies should slightly move, and they do. Okay, but this isn't moving nearly as fluidly as it should, okay? So when you're tearing your carburetors down, make sure you go through this. Now again, there's a spring and a device in there, so you got to be very careful when you tear that apart that you don't lose those items, okay? Now, directly in front of it, right here, this brass plate with a spring over it is actually what the butterfly rod is attached to. Okay, that's the spring load to bring the butterfly rod back up. I've actually gotten a pair of fantastic 45s because the butterflies didn't return, and I got them for 50 bucks, and all it was the return spring was broken, so it was a simple fix. Now keep in mind, the most common carburetors Weber offered were the 40s, the 45s, and the 48s. There is a time and place for a 48, but that is a really big carburetor, so you must have a monster motor that needs a lot of fuel and air delivery to it to justify using 48s, but I most certainly have seen them on track cars. Okay, so anyway, moving back to where we were at. Alright, so right now, to the exception of these two items right here, everything else up here is associated with the starting assembly of the car. Okay, so what we have right here at the very front, I'm going to try to back this out, and again, the right screwdriver for the job. I'm backing this out, and what I'm backing out right now is actually the starter jet. Okay, so this is the actual starter jet. Alright, there's a starter jet and holder. Alright. And you can see there's a lot of debris on that, so that always needs to be cleaned up. Don't get aggressively, ambitious about cleaning these. I used to actually polish these up. That turns out to be a bad idea. Sometimes the coarse surfaces of these items help break up fuel and keep them off of the holders and whatnot. So don't polish them, but most certainly clean them very well. Okay, so if you're going to tear down your carburetors to clean them, you should get every brass fitting you can out of it first, okay, because they're essential to the actual performance, the overall quality of fuel delivery of the vehicle. So right now, what I'm taking out, you see this item right here. First test you should do to find out whether this is even working properly or not, you should press down on. This is their starter valve system, okay, and that spring moves quite well in there. That's returning quite nicely. So, and it has a little split washer on top of it. Okay, this is what the split washer looks like. Okay, so when you take that out, you'll have an assembly that basically looks like this with the spring. And if you look right here, this is what I'm focusing on right now. This should be, you can see that this is the starter valving system, and this is dirty. It's got a lot of carbon buildup on it, and it shouldn't be that way because this needs to be fairly fluid when moving into the actual carburetor. Right now, that fell in there quite well, but it didn't come out as easy as it looks like it did. It was actually seized, okay? And those should not be seized. They should move very fluidly. So, the reason we took off the choke assembly is so you can see all this stuff and see what happens here, okay? All right, so anyway, there's notches in there. You see a little notch here and there's a little notch here. If you take your choke assembly up and you turn it around, those notches line up to these bars. Okay? So when you pull the choke in your car, if these are nice and smooth, when you pull a choke, it's a very fluid experience. If these are seized, the choke doesn't want to move, or the choke doesn't, advance the carburetor like it should, and you have a hard starting experience. But effectively, the starting circuit becomes almost useless if this assembly associated with the choke isn't working right. Now, the last component that's in the starting circuit is back here. I'm not going to take this out because there's a little itty bitty ball bearing at the bottom of this. All that's underneath here is a little, what they call a packing rod, and the ball bearing at the very bottom. You don't want to lose that. So I'm leaving those alone for now because this is just demonstration purposes. So now that we know this entire area is basically associated with the starting mechanism of the vehicle, we know this particular area is the idle and the main jet system. Now we need to start focusing on how all this works. Okay, so you got a good idea of what these items are, and we're going to fall back and talk about, the idle mixture, the progression circuit, and how all this comes together. Okay, that's the next segment on this. Okay, so the next phase we're going to talk about is the actual tunability of the carburetor from, a running vehicle, if you will. Okay, we're going to talk about the idle adjustment screw. One thing I like about Dellorto over Weber is the fine thread fitting on this. I'll take this one apart. The spring's imperative, but the Dellorto idle mixture screw, the threading is much finer thread than this. So, if you really had this knack for super dialing them in, theirs is a little easier to do than the Weber is. After the idle mixture screw, the next one is the progression circuit inspection plate, which is this one plate. Now again, we know these to be performance carburetors because when we look inside of a progression circuit, we can see there's only 2 holes in there instead of greater than 3. All right, and then the last one right here is the accelerator pump cover. Accelerator pump cover has a little O-ring on it that's rubber. Now when you're tearing these apart, if that O-ring is hard, no longer of a rubber nature, get rid of it. Don't use it. This particular one's very hard. The other thing you need to be aware of, when you take the accelerator jet out, the thing you need to be aware of is on the bottom of this. Now mind you, I pulled it straight out like that. On the bottom of this, there's supposed to be a little itty bitty aluminum washer. More times than not, if it's not there, it's sitting at the bottom of the carburetor. But sometimes somebody tears them apart and loses that. If that washer isn't there, the performance of this is going to be greatly diminished. In this particular case, half of it was there. Only half the washer was there. Where's the other half? Interesting question. I'm sure I don't want to know the answer. Alright, so this is all a part of the acceleration process of the carburetor. Now what I'm going to do is I'm going to try to help you out here to see this. But in this case, you can see, let me see how I'm going to do this. Okay, we're going to pay attention to this side. Alright, what you can't see because it's so tiny is there's a little itty bitty hole right here. Okay, that little bitty hole is for the idle adjustment screw. That little itty bitty point comes through the top through that hole, and based off of how much you back it out and allow fuel in determines the actual set idle of the carburetor. But you can see there is a black ring of basically backfire or carboning gases around here, and there's a little V right there. That V is because the progression circuit, and mind you, I only have 2 holes in my progression circuit, are right there. Okay, so that's essential to know where they're at, and you can see the process. Basically, the way it works is carburetors like this in an idle state, butterflies are somewhat closed. Okay, if the butterflies have to be opened then there's a problem with the performance of the carburetor. So the carburetor should be basically closed. Idle fuel mixture is seeping through this hole right here to keep the engine running. And as the vehicle opens the butterflies slowly, the butterflies pass over the progression circuit. That passing over the progression circuit is allowing the air that's being pulled in from the motor to pull fuel through the progression circuit. Okay, so that's how that works as far as performance. If those were big bull hunking holes in there, and a bunch of them, then what's going to happen is you're going to get a lot of fuel mixture, and what that does is it keeps the vehicle from basically running a little lean, keeping the performance down. It's effectively what it's really doing. Okay, so that's how that circuit works. Okay, so that's the last phase on that. Okay, so now we're moving on to the auxiliary venturi, which is the first segment you see inside the actual carburation tube. And then underneath it is the choke. Now the thing of it is this beginning piece, I'm going to take this out first. Now, something to note, on 45s you usually see a set screw right here. These are locked down with a set screw. It is essential that once this is all assembled, that these don't have any slop in them, no movement, because this really affects how the thing performs. Okay, so now I'm taking the auxiliary venturi out. There's something we need to know about this before we go past this. The auxiliary venturi is really key to the overall ability of the carburetor to perform to your motor, okay? And if you look at them, like most of the parts on here, any part that's interchangeable on these has some kind of performance number on them. You need to know what those performance numbers are. Now this particular one right here is a 4.5. I can see it right there underneath the spring load, okay? So it says 4.5 right there. Now, basically the way these things work is typically you see anywhere from 3.5 to 5.0. And that what that reference is the overall cc per cylinder on a motor. Now this particular one is a 4.5. 4.5 auxiliary venturi is good for up to 500 cc's per cylinder. Alright, so if I'm building a really, really hot 1750 or a really good performing 2-liter, using my DCOE 42s, I'm right there in the sweet spot with this particular venturi, because this is good for up to 500 cc's. Okay, so basically the way it works is a 3.5 auxiliary venturi is good for up to 300 cc's. A 4.0 is worth like 400 cc's. 4.5, which this is 500. And a 5.0 is I think 500 and beyond is basically how it works. All right. Anyway, so the way this little guy works is when the fuel has been emulsified and it's blended with the air and it's coming down into the carburation, it goes through this hole right here, and the air coming through here creates a vacuum and it pulls it right through that wick in the middle. So that air fuel mixture comes through that tube and it joins all the air being pulled in from the carburetor. So now you have a ton of emulsified fuel mixed with a lot of air, and it heads to the cylinder for combustion. So these little guys should be really clean. Don't over polish these, because it does affect the air performance. And we'll talk about air turbulation and ram air setups and all that kind of stuff later. And don't worry, we are going to go back and explain the actual performance issues with everything associated with it, whether it be the pump jets or whatever it is. We will go back and single-handedly discuss each one of those items. But for now, we're just getting you familiar with some of the components. This being the auxiliary venturi, this particular one being a 4.5, this is good to up to 500 cc per cylinder, just so you know that. Now this is where I was referencing earlier that I'm taking the choke out right now. This particular choke, the casting on it says it's a 34. That's where they always have them, is right there. Okay, so this particular one's a 34. That also works in line with where these carburetors will eventually be. Now the thing of it is, the way all that kind of ties in is on 40s, DCOE 40s, you have a range from 28 to 34 on chokes. On 45s, it starts from 34, which is these, and goes up substantially from there. So when you see somebody who's running a set of DCOE 45s and they got it choked all the way down to 34, you got to wonder whether that was really a necessary carburetor to have on that. So that's what I'm saying. Having the bigger carburetors does not mean that it's a better performance experience. It actually can hinder the car's performance, whereas a good, well-tuned set of 40s can be probably even better for your motor. And again, DCOE 42s, I don't expect anybody to go out there looking for these because these are hard to come by. They just happen to fit that crossover blend where some of the motors we build that are running on carbs. So anyway, so you need to know your choke sizes in order to set up your motor appropriately. You need to be fairly familiar with the auxiliary venturi sizing to make sure it's matched to the CC of your motor. And then obviously everything else we discuss is associated with that. Now, this is probably going to wrap up this particular video. So when we go back through this, we're going to start talking very specifically to each individual component, so you can get a better familiarization as to what their actual job is, whether it's going to be the idle jets, the main jets, the starting circuit, which we all know what that is now, whether it's the fuel pump delivery system. You know, there's tons of things, if you really think about it, you kind of got exposed to right now. So when we move on into the next segment, we're going to talk about proper selection of jettings for your car. We're also going to talk about the importance of the butterfly values. Each butterfly, by the way, has its markings on it as to tell you what it is. If you tear these things down, there is a right and wrong way for these butterflies to go in. The stamp numbers, whether the Webers or Dellortos, it doesn't matter. The stamp number should always be legible on the bottom. It shouldn't be to the inside, it shouldn't be upside down, it should be right where you can see it right there. Okay? So that wraps up that video, and we will carry on this video later, and we will move on to talking about how to tune them, and we will also show you the pros and cons of carburetors over Spica and Spica over carburetors and where those applications are best suited. And we will have the experts that are associated with those items, you know, chime in and talk about those as well. So, you know, again, this particular video is just a basic entry to explaining some of the features of a carburetor. We will go into the next video explaining very specifically each one of these components' jobs, and then we'll talk about how to set up the carburetors for ideal performance, and then we will talk about where carburation falls short and Spica fuel injection picks up that difference. So we're going to try to make this a series that's more well-rounded and suits everybody's needs. So I guess that's wrapping it up for today.